look at reactions of alcohols themselves. Now, these are the guys that are the reactants, okay? So we want to see how they react. Now, I think of the whole list, I'm going to start with the first three that I think deserve particular attention, right? And let's go with the first one. So the first one is going to be dehydration. Okay, we saw that hydration was hydration of an alkene to form an alcohol. Now we're going to be dehydrating the alcohol to go back to an alkene. Now this is a very easy reaction, but the only reason I'm doing it with you is because it has some conditions. Okay, so you'll be having an alcohol, could be like this. Put propanol here, and we are going to say this is the OH. Okay, and then here, of course, you have the hydrogens, blah 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 blah. Hydrogens. Remember that carbon always has 4 bonds, right? Every carbon should have 4 bonds. There we go. Now this guy is going to react with an acid, okay, with a strong acid. And you're going to have to put it, say, H plus, and remember, it'll be a strong acid. So that's how we do it, strong acid. But you would need to heat it up. So you would heat it up to more than the boiling point of water, 180 degrees. And then this would lead to the dehydration. So how it dehydrates is this. OH goes, and then you're going to take H on the next carbon. So on one of the carbons, OH goes. On the next carbon, you take an H. So at the end of the day, what we're going to have is, this guy is unchanged, but this one now has a double bond with the last one. So these two now will have a double bond, right? Okay, and then obviously now what we would have is here an H and an H, and then this one we have one H. So, okay, we could put it up or down, doesn't matter where we put it. So what did we do? We took an H on one and the OH. So, and they go, and what would they give us? Of course, these two would then give us the water. So this is what happens, and that's what you need to know. Strong acid like HCl or H2SO4, which is the same thing which we did in hydration. Hydration, we put an acid. Don't forget that, but we didn't have temperature and stuff, but we used an acid again. Okay, and remember that it had a reaction mechanism. So for here, it's like this. We could just put it, you could see something like this, huh? Ethanol in bond line. This is OH, then they put H. Say, how many carbons are there here? There's one here, and there's one here. So 2, okay? This is not a carbon because it's an OH here. There's an H, it's not a carbon. So we have 2, okay? So this is, and it's an alcohol. You can see the OH. So this is ethanol, right? If we reacted with your acid, okay? If we reacted to the acid, even if we say plus HCl, then we say here 180 degrees, okay? 180 degrees Celsius. That's one of the things. Or you could see them just put an arrow and say H plus, that's an acid, and then we say strong acid, okay? Strong acid, then 180 degrees Celsius. Remember, it's even if they just give you as the acid to say this plus acid, what are we going to get? What are we going to get? Dehydration. If we add an acid to an alcohol. So what's going to go? OH. Then what happens? This OH is from this carbon. So we go to this carbon, we remove the H, right? So what are we going to have at the end of the day? Ethene, and then plus H2O. So we have ethene plus H2O. There's a double bond now between these two guys. And that's it. You'll be done. And that's what you do. Now let's go to the second one. Remember we said we are doing 3 that could be challenging. So here, on the second one is, if you remember, we saw that if I have an let's say a haloalkane, we saw that if you have a haloalkane, R, whatever it was, then a Br. We saw that if you add NaOH, then this Br is going to freak out, right? OH will go where the Br was, then the Br will go to Na, you'd have NaBr. Now, what about if I want to put it back? We've removed the Br, okay, and we got an alcohol. What if we want to remove the OH and put back the Br? Where we have warriors, and the warriors are, warrior number 1 is going to be HBr, okay, or HCl, or whatever. Basically, we'll call this a hydrogen halide, okay? Hydrogen halide. That's the first one. This guy can push back the halogen into it will push it back to make a haloalkane. Remove the alcohol, make it. Second guy, second hero is SOCl2. Okay, this guy can push back chlorine. Yes. Okay, you can have it. Now the other guy that is important again is going to be, we can say PX3, okay, which is PBr3 or PCl3, okay. X here represents group 7. So these are the three warriors that we have. These guys put back halogens where the alcohol was. So the where the hydroxyl, the OH was, they're going to remove and put in alcohol. So what's going to happen is, we just want to know where does, who works where. So basically, this guy, this HBr, the hydrogen halide, it works when you are going to have tertiary alcohols. Okay, we want to remove them from being alcohol. So when you have tertiary alcohols, then oh my gosh, he is the best hydrogen halide, the best. Okay, but if you have primary or secondary alcohols, okay, remember tertiary are the 3 degrees. Okay, tertiary. If you have primary or secondary alcohols, then you can use this guy, SOCl2. Okay, right? And PCl3. They only work on primary and secondary alcohols. Okay, to be honest with you, HBr, you can see it working on any, but for the case we're going to use, he's going to be working on tertiary. So here's C, R, R, R. That's a tertiary carbon. Okay, carbon connected to 3 other carbons. Okay, we could say R, then R prime, then R prime prime. That's another way you could do it. Now, he's just going to meet. Here there is a mechanism. Mind you, this is a tertiary alcohol. He's going to meet HCl or HBr. Okay, so HCl or HBr. Then what's going to happen is, we are going to first form an intermediate. So it's going to be like this. C, R, 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 right? This guy is bonded to, instead of OH, the H goes here, okay? So you don't put an arrow, you just put it as OH2. But now because it's an OH2, you put a plus. Because what happens is oxygen donates one of his lone pairs to this H. Now look at what happens. So you form it like this. And what you're going to do is, you put an arrow. This guy is going to undergo what they call SN1 substitution. This means this SN1, what it means is this. We say S, then N, then 1. What it means is the substitution nucleophilic first order. What it means is, you'll be having somebody like this who is going to break into a carbocation on his own. So look at him. He's like this, right? What's going to happen is, the 2 electrons from this bond are going to go to this OH2, and is going to fly away as an H2O, and you remain with a carbocation. So this carbocation was not attacked by anyone. He split on his own. So that is why they call it SN1. He split on his own. Now when it's like this, this guy, the Cl minus or the Br minus, from this first step would just come back, and what would they do? They will now react, and you will get your tertiary thing. Cr, R, okay, R again. I'm writing it this way because I don't have space. And it's now bonded to Cl or Br. And you have 1. Well done. So here is what you show, and this is what happens, right? What is this? Tertiary alcohol. Okay? And what did we use to put back the Br into the alcohol? We used HBr or HCl. We use a hydrogen halide. Now, what about the primary and secondary? What do we use? So, primary and secondary alcohols. Okay? Alcohols. Let's put alcohols. Yes. What do we now have in primary or secondary alcohols? We will now have SOCl2. So we have an alcohol. This is what? We can have it as a primary alcohol, right? reacting with your SOCl2, then what are you going to get? You are going to get this Cl go to OH, basically RCl. And then what is important here now is that you are going to get byproducts that are going to be HCl and SO2, okay? And SO2. And sometimes you see them put them with arrows like this. I'll explain to you just now. Now, what about if I have same thing? What about if I now have the same thing, ROH, and it is reacting with PX3? Okay, what is it you do now get here? We need to put 3 moles of it now. When it reacts with PX3, you now have RCl. Of course, the OH goes, we put the X. Okay, so let's just say RX. Okay, whatever the X is, plus you now have H3PO3. Okay, that's going to be your byproduct. So you have 3 moles of RX plus H3PO3, and that is what you're going to have. Now, what you must know is here I used SOCO2, here I used PX3, and that is what I got. When I used SOCO2, I got this OH went, and I had the Cl come. Of course, here's the group 7. And the byproducts were HCl and SO2. Okay? Here the byproduct was H3PO3. Now, what you must know is that this first one here, where you put SOCl2, this one is not effective. Okay, it's good. Let's say it's good for RCl is called an alkyl halide or an haloalkane. Okay, it is used for alkyl halides, or let me say it is used for haloalkanes. It is used for haloalkanes with high melting point and boiling point. That is what you use it. You can't use it for low melting, guys. You know why? Because when you use SOCl2, you would need to hit that thing. And if you use an RCl with a low melting point or boiling point, it's going to turn into a gas. If it has a low boiling point, it's going to turn into a gas and go away. Go away with who? With HCl and SO2. Because HCl and SO2 already have low melting and boiling points. These guys, HCl has a negative melting point and a boiling point. Same as SO2. They have crazy low boiling points, so they don't work. But this H3PO3 is an animal. His boiling point is about 75 degrees Celsius. That's a high one. These guys have negative, guys, so they turn to gas even at room temperature. There will be gases. Here you have your HCl. He is going to turn to a gas very fast. Okay, he's going to turn to a gas very fast, and he's going to be. So basically, because we heat this mixture, because this SOCl2, let's just say, simply because we heat this SOCl2, we can't use the haloalkanes that turn into a gas fast. Because this reaction will not be effective anymore. But for this PX3, it can work for low melting alkyl halides. Okay, so it works for low melting alkyl halides. So what did we see so far? We saw that we have dehydration, and in dehydration we add a concentrated acid, right? Remember, we had a strong acid. Let me say strong acid. We heat it, and we know OH and H go. Then here we saw that we have 3 guys, HBr, SOCl2, and PX3. These guys are great. They turn our alcohol back to a haloalkane. And we saw that when we do the tertiary alcohol, when we add the H, we do a small mechanism. And in our mechanism, the first thing that happens is H comes here. We get an OH2. But then the O is going to be a positive one. So we now show electrons coming from this double bond going to oxygen. And what's going to end up happening is when they go there, you have H2O breakaway, and you remain with the carbocation. That carbocation now meets the chlorine, and it will now form your haloalkane. Now for primary and secondary, we just saw that you meet it with SOCO2 and PX3. But remember, SOCO2 is not for guys with low melting points, okay, or low boiling points. It's for guys with high ones, high boiling points, not for low boiling points, right? Now the last, okay, we'll do it in the next video, maybe the last one, and we'll see it.